Alright, so we're going to do lesson 12.2, which is operations with radical expressions. First of all, yesterday we went over what a radical sign is. All it is the square root sign. So today we're going to be doing addition, subtraction, multiplication, and division with radical signs. So before we even do these examples, okay, we're going to go back and we are going to kind of go over some things we did at the very beginning of the year. 1x plus 2x. Can I add those terms together? Yes. The reason why is they are like terms. So 1 plus 2 is 3, and whatever that like term is, I keep it. They all have an x, so that like term has to stay the same. But if I were to tell you to add x and x squared together, I cannot do that because those are not like terms. They don't have the exact same variable. Okay? If you can understand that, you can know exactly how to do addition and subtraction with radical expressions. Okay? This problem right here, what the like term is exactly what is underneath the square root symbol. So every single one of these terms has the square root of 7. So that means they all have a like term. As long as they have the same number underneath the radical, that is their like term, and I can just add or subtract what is on the outside. So I say, okay, what's 3 minus 5? Negative 2. What's negative 2 plus 2? 0. I keep the exact same like term, the square root of 7, because I'm not going to make it the square root of 21, just like I didn't make it 3x squared. Okay? It stays the same. Well, what's anything times 0? 0. So that would be my final answer. Okay? Now let's look at a problem like this. I want you to write this down. Okay? Ask yourself, are they like terms? Yes, they are. They both have the square root of 2. That's all you have to have. Now, if I were to ask you to add x plus 2x, what would you tell me the answer was? 3x. The reason why is even though there's no x right there, I know it's an unwritten 1. That is the exact same thing when you have a radical. Even though there is no number there, there is an unwritten 1. So now I have 1 plus 2 is 3, and I keep my like term, which is 3 times the square root of 2. Now, what if I would take this exact same problem, but I'm going to do plus 5 times the square root of 3. What are my like terms? Just the square roots of 2. Now, the square root of 3, 5 times the square root of 3, does not have a like term. So I just add my like terms, 3 times the square root of 2. And then since I don't have a like term for 5 times the square root of 3, I just write it on the back. There's absolutely nothing I can do to simplify that any farther. Okay? Now, let's look at this next problem here. 8 times the square root of 5 plus square root of 125. Are they like terms? No. So I know I can't add them together. But what can I do to the square root of 125? Simplify it. Okay? In order to simplify it, I have to do upside down division. Does everybody remember that? So I have to ask myself, what's the smallest prime number that goes into 125? 5. That leaves me with 25. What smallest prime number that goes into 25? 5. And I'm left with 5. Now, remember, I look for a pair. A pair is 2, okay? So I have 2 5s right here. That pair becomes 1 5. I don't say, oh, add those together and get 10, or multiply them together and get 25. No, the two of them just become 1 5. And where can I put that 5? On the outside of the square root. Whatever I have left goes back underneath the square root. Now, let's say I had, like this one, I only have a 5 left, so I put the 5 back underneath there. But let's say I had a 5 and a 2. What would I do with that 5 and that 2 to put them back under? multiply. So I would have 10, and I'd put 10 back underneath the square root. Okay? So now I have 8 times the square root of 5 plus 5 times the square root of 5. Are they like terms now? Yes, they are. So I can add them, and I get 13 times the square root of 5. Okay? Let's do this one. Square root of 3 plus the square root, 2 times the square root of 12. What would I have to do? Oh, I don't know why that didn't show up. Okay, what would I have to do first? I need to simplify the square root of 12. So I need to do upside down division. 2, 6, 2, and 3. So I have a pair of 2's which can come out and make 1, 2. Now, I already have a 2 on the outside. So what am I going to do with those? Multiply them. Very good. So I have 4 times the square root, and what do I have left? 3. Now can I add these together? Yes. What is this number right here in front of the square root of 3? 1. So I have 5 times the square root of 3. Okay? Okay. So let's do the next example, which is multiplication. Okay? Now, again, we're going to go back to the beginning of the year really quickly, and let me remind you of something. If I said x times x squared, what would that be? X cubed. Now, look, I can multiply these even though they're not like terms. On addition and subtraction, I can't add or subtract if they're not like terms, but multiplication, you can always multiply if they're not like terms. They do not have to be like terms. Now, there is only one rule that's going to be different when you do multiply square roots, okay? If it has a square root sign, whatever is under the square root can be multiplied by another number under the square root, okay? If you have, let's say I have 2 times the square root of 3. I cannot multiply that and say the square root of 6 because they both did not start out underneath the square root. So I can't just automatically put it under there. If I have a whole number, it has to be multiplied by another whole number. Well, what's the number right here in front of the square root of 3? 1. So 2 times 1 is 2. And then I leave the square root of 3. That's how you would have to write a problem like that. Okay? But when you have the square root times the square root, I'm free to just multiply the numbers. And as long as they both have a square root sign, I've got to keep them underneath that square root sign. So 12 times 3 is 36. What's the square root of 36? 6. So that would be my final answer there. Okay? Now this next example, what does it look like I need to do? I went to the one right below it. What does it look like I need to do? Distribute, exactly. If it looks like distribute, you distribute. Now, can I multiply the square root of 3 times 7 and get the square root of 21? No. How do I have to write it? The 7 goes on the outside, and then the square root of 3. How that's read is 7 times the square root of 3, just like that. Okay? Now, the square root of 3 times the square root of 15, can I multiply those together? Yes, because they're both underneath the square root sign or the radical sign. And I get the square root of 15. Can I simplify the square root of 15? Yes. Let's try it. What's the smallest prime number that goes into 15? 3. Did I end up with any pairs? Nope. So guess what? Even though 15 looks like it can be simplified, it can't. There's nothing I can pull on the outside. So are these like terms? Can I add them together? Nope. So this is my final answer. There's nothing I can do to simplify that. Okay? Now let's look at this next one. In our factoring chapter, we learned that when I have a squared on the outside of parentheses, what do I do? Write the problem 2 times. Exactly. So I'm going to write 1 minus the square root of 3 times 1 minus the square root of 3. All that means is I write what is in parentheses twice. Now, what do you think you're going to need to do to this?
FOIL.
FOIL is correct. Okay, so I want everyone paying attention here because this is the part that you can get confused on if you don't pay attention. First terms. 1 times 1, which is 1. Okay? Now, outside terms. This is where I want you to pay attention. 1 times the negative square root of 3. I cannot forget about that sign. So this is how you write it. You always write the sign first. So I know it's going to be a negative, then the whole number, 1, then the square root. So negative 1 times the square root of 3. That's exactly how you do that one. Okay? Now, outside terms. 1 and negative square root of 3. Exact same thing. I need to write the negative sign first, then the whole number, then the square root of 3. Okay? Now, last terms. I've got the negative square root of 3 times the negative square root of 3. I cannot forget about those negative signs. What's a negative times a negative? Positive. So I want to go ahead and write that positive. So now I don't even have to think about it. Let me tell you a shortcut that's really going to be helpful to you. Anytime you have square roots and they're being multiplied, and what is underneath the radical is the exact same number. The square root of 3 times the square root of 3 is always going to be 3. Just like the square root of 5 times the square root of 5 is 5. Square root of 6 times the square root of 6 is 6. Square root of 10 times the square root of 10 is 10. Okay? And this is the reason why. Let's say we actually multiplied it out. Square root of 3 times the square root of 3 is the square root of 9. What's the square root of 9? 3. So all I did was save you that step basically. We just go ahead and write it as a whole number. Now, what I'm going to do is I'm going to combine like terms. So I know that I have a 1 and a 3 that are like terms. So 1 plus 3 is 4. Then I have like terms, negative 1 times the square root of 3 plus negative 1 times the square root of 3. They both have the square root of 3, so I know they're like terms. Negative 1 plus negative 1 is negative 2 times the square root of 3. Is there anything else I can add together? No, because nothing else is like terms. I can't do 4 minus 2 and say 2 because they're not like terms. So this would be my final answer. Okay? Now the next problem I have. Exact same approach, only this time they've already written it out for us. Okay? But what do you think I need to do in order to solve this? FOIL. So 6 times 6, my first terms, 36. 6 times positive square root of 2. So what has to be written first? The plus sign. Then comes 6. Then comes square root of 2. Okay? Now, inside terms, what has to come first? The negative, the sign. Then what comes next? 6. Then square root of 2. Now, my last terms. I've got a negative square root of 2 times a positive square root of 2. What is that going to become? Negative. So I go ahead and write that and get my sign out of the way. So what's the square root of 2 times the square root of 2? 2. Now I combine like terms. 36 minus 2 is 34. And then these are my other like terms. Positive 6 times the square root of 2 and negative 6 times the square root of 2. What happens when I add them? They cancel out. They get 0. So 34 is my final answer. There's nothing else I can do to simplify that. Okay? Okay, so let's do the last example. Example 3, simplifying radicals. Now we're doing division. The first example, we did addition and subtraction, and they had to have a like term. The second example, we did multiplication, and I could multiply anything together as long as they both were either underneath the radical or both were outside the radical. And now we're doing division, okay? Now, division. In order to simplify a fraction, I can never, ever, ever have a radical in the denominator, ever. Okay? So I've got to take care of that. When I see a fraction that is not in the denominator, or I'm sorry, that is in the denominator, I have to fix it. And this is exactly how you fix it. You just multiply by whatever is in the denominator. So in this case, the square root of 3 is in the denominator. So I multiply by the square root of 3. Whatever I do to the bottom, I've got to do to the top. What's the square root of 3 times the square root of 3? 3. So that tells me right there, that takes care of my radical. I no longer have a square root in the denominator. Now I just multiply what's up top. 1 times the square root of 3 is 1 times the square root of 3. This is my final answer.
Couldn't you just write the square root of 3?
No. Oh, instead of the 1. Yes, I'm sorry. Yeah, if you wanted to write the square root of 3 over 3, that's fine. You don't have to write the 1. Okay? I'm going to give you this problem. I want you to do this one. 2 over the square root of 2. Okay, what would I do first? What do I need to multiply by?
The square root.
The square root of 2. Whatever I do to the bottom, I have to do to the top. What's the square root of 2 times the square root of 2? 2. Then up top, I have 2 times the square root of 2. Do you see anything you can simplify? The 2's. Those 2's right there cancel out. They're both whole numbers, so they're okay to cancel out. Now, I wouldn't be able to go, oh, those 2's cancel out because one's in a square root and one's not. But you can cancel out 2 whole numbers. So I'm left with the square root of 2, and that would be my final answer there. Okay, last example. Now, on this problem right here, we have 4 over 3 plus the square root of 2. I said you can never have the square root sign or a radical sign in the denominator. So I've got to multiply by what's exactly in the denominator in order to get it out. But when I have 2 terms, okay, this is exactly what you do. I am going to multiply exactly what's in the denominator, but instead of the plus sign, I'm going to put a minus sign. Whatever sign it already has, you do the opposite. So it's almost the exact same, but you do the opposite sign. Now, whatever I do to the bottom, I've got to do to the top. And what do you think I'm going to do here on the bottom in order to multiply those? Foil. So, first times first is 9. Now, 3 times the negative square root of 2 is going to be negative 3 times the square root of 2. Then, positive square root of 2 times 3 is positive 3 times the square root of 2. And then I'm going to have a positive times a negative, which is a negative. Square root of 2 is 2. Okay? What happens to these terms right here in the middle? They cancel out. Guys, that is the whole point. Because if those terms don't cancel out, you're still left with a radical in your denominator. And then you didn't do anything that you were supposed to do. Okay? Those terms have to cancel out. That's why you do the opposite sign, so that they will cancel out. So my denominator, I have 9 minus 2, which is 7. Okay? Now I just need to distribute this 4 to everything in the numerator. 4 times 3 is 12. 4 times negative, what's that number right there? 1. It's going to be negative 4 times the square root of 2. Is there anything here I can simplify? Are they like terms? Is 12 minus 4 like terms? No, because that 4 has the square root of 2 behind it. So this is my final answer. Okay? Now, let me clear up one thing really quick. You cannot. I have a lot of people go, oh, all I need to do is multiply by the square root of 2. You cannot do that. The reason why is if I do that, I've got to distribute that to everything. So I'd get 3 times the square root of 2 plus 2. Did that take a radical out of my denominator? Nope, I still have one right there. So it didn't do anything. That's why you have to multiply everything that's in the denominator except you just change the sign. Okay? So that's how you multiply, divide, add, and subtract radicals.